Well, hey everyone. So I am finally starting to get a little bit of free time and have been working on a dialogue system for my game. And I wanted to talk a little bit about what's powering it. Because what I am basically doing here is implementing I guess you could call it a flavor of the basic programming language. And I guess maybe the first thing to talk about would be why. You can see here I have a little demo scene, and I've been working on integrating the dialogue with the basic backbone behind this, and I have not gotten so far in the forward-facing aspect of this, but the implementation of basic itself is getting pretty close to done. So one of the reasons why I'm doing this in the first place, I'll just say, if those of you that are familiar with Stencyl may have heard of plenty of other solutions are hard to getting dialogue in games. Probably one of the most well-known to be the dialogue extension. Of course, there's also Lurin's cutscene resource pack, a few others I don't quite know the name of off the top of my head, but I've seen them crop up in the forums, and I'm actually hardly the first to implement some kind of scripting language either. Good reasons to do this would be if you have just a lot of little small scale programs. It doesn't always make sense to hard code those, in particular with dialogues. So the problem is, there are a lot of branches with conditionals and checks and all kinds of things with the dialogue. If you've done certain things, you can unlock certain features in the map or unlock certain unlockables, things to purchase in the store, etc. So I really needed something that was more flexible. Plus, as far as having a general purpose scripting language, I could then use that for other things, such as powering NPC AI, or adding a little bit of I guess I'll just say functionality to maps. In particular, I'm thinking about the isometric game, which once I'm done with Rogue of Vallas, I would like to get back to the next installment of that, and having something to operate, moving floors and elevators and switches. I'd much rather not hard code that meaning as part of the compiled game, but rather have a script run that could potentially be modified by the player. If someone wanted to mod the game, I wanted to make that relatively easy to do. The problem with Stencyl's scene editor is, and there actually is someone working on a way to edit the scenes outside of using Stencyl, but certainly any programming, you would have to have the source code to do that. So in this update, I'm going to talk a little bit about my particular flavor of BASIC and how I've gone about implementing that in Haxe or Stencyl, more so Haxe actually. Let me get out of here and kind of show you a little bit about, not that this is going to be much of interest to see, but the code here that I'm working on, 1,800 lines and counting. So this is not a small scale project, but one thing that I can point out here, you scroll back up to the top or near the top, kind of the way I've approached this. So if you're familiar with Visual Basic, and I do mean like the older ones, I've never used Visual Basic.net, but VB3, VB6, the way these typically worked is you would install Visual Basic, and you would have a toolbar with your basic tools like buttons and scroll bars and text input boxes and the like. And that was your basic functionality. But you could extend that through, I guess, third-party add-ons or even first-party add-ons. I think Microsoft might have made a few of these themselves. You could add additional functionality to have some tools for interfacing with the database, or with, they call it OLE, I don't remember exactly what that stood for, or modems, or whatever else you could get an extension for. I've kind of taken the same perspective with my, for all practical purposes, I'll just call it basic implementation, scripting language. I don't know, The semantics I don't think really matter too much with this, at least not to me. But here I have my basic functionality, and these would be the keywords that you would more or less expect with QBasic, which has really been my reference, I guess you could call it that, for this. Begin, if, conditionals, next, or for next, while, when, etc. I have labels, I have goto. I'm working on functions and function calls right now, so this is the only part of my language that's not working at the moment. But pretty much everything else is, and this is your basic functionality. But then, just like with Visual Basic, you would have those add-ons. I have add-ons for interfacing with dialogue. I have add-ons for interfacing with Stencyl actors. In fact, I can show you another demonstration here. Let me go back to, there we go. Load up the console. A second here, I'll get that. There. Load up the console, and I'll load ball test, and we'll execute it. Which, by the way, there's a difference between run and execute, which I'll get into at some point. Basically, run just executes one line at a time, whereas execute will execute every line until it gets either to the end of the program itself or a wait. There we go. There's my little add-on that lets me interface with the Stencyl actor, and I'll point out that that green ball there is not being controlled by a behavior, an actor behavior. It's actually being controlled by the basic program itself. In fact, I have no way to stop this. Yeah, maybe I do need that, but I can relaunch this here, and let me load that program again and list it. Unfortunately, my console right now does not have scrolling, so you're only looking at the bottom half of the program, but you can kind of see a little bit about how it works. Set sets the value of a variable. Pset sets the value of a property, such as the x and y coordinate of the ball. One thing I'm going to point out is the font I'm using is missing some of the characters. So, for instance, you do not see the inequality here that should be there. That little space there is where an inequality should go, and then there's actually a $ that should be in front of the parentheses for the x and the y. That's just the way I handle, I guess you could call it substitution. Substitute the value of the variable x and y into the string. Not that print's really going to be of much use for the player, but for me, in debugging purposes, that's having that print statement there is very helpful. In fact, if I want to start talking about challenges, so there have been some things that I thought would be hard and turned out to be easy, and then some things I thought would be easy and turned out to be hard. I mean, that's usually how these things go, right? One thing I didn't think about was when I ran into a bug with one of my programs, because now I have the fun part of figuring out, well, do I have a bug with my test program, or is the bug in the implementation of the language itself? And in the case of this ball test here, it turned out I ran into both issues, and sometimes both at the same time. I'm going to split this update actually into multiple parts. So in this first part, I'm not going to talk about how execution works, in part because I'm still working on that actually. I wanted to make some changes. But what I do want to talk about in this update is how loading works. And it's not quite as straightforward as it might seem. So let me load another program here, if test. So all this program does is just check that my implementation of conditional statements if, else, and end if worked. And it does work. And that also verifies that the for loop is working correctly. So, if the for loop is working correctly, then in each iteration, exactly one of these three print statements should display. In fact, they should display in the right order. Keep in mind, there is an equal sign here that you're not seeing. And then we have the output, and it's in the right order. So that works. Now, let me go back to actually, let me load up. I have it down here. Here we go. Let me load the program itself. So this is the program that you saw. But there's one difference here I want to point out. So when a program is read, leading white space, which would include these tabs, is eliminated. If you're familiar with the usual string tools that Haxe provides, I use the ltrim method that trims leading white space from the left edge. So all those tabs are deleted, but when I listed the program for you, you saw that we're there. Well, that's actually a verification, and this is one of the things that I knew would be challenging, and actually kind of hit par. It was about as challenging as I thought it would be. And that was loading the program and identifying where the blocks of code were. So here's the problem. All of this content right here is considered the block of code for the for loop, whereas this particular line of code is considered in the block for that if. So as I'm reading this program, how do I know what lines of code are embedded in certain control structures? Well, to make sense of this problem, let me outline the general approach I'm taking to a program in the first place. So what I need to do here actually is let me make a new layer. I'm using my paint for this, by the way. Make a new painting layer so that way I need to hide that window here. Well, I can't seem to hide that. There, I got rid of it. Okay, so the general approach, I'm taking actually kind of a graph theory approach to this. So graph being, nodes and edges. So the entire program itself, called a VD script, which by the way, I call this VDS basic. VD is for Vallas dialog, so it's Vallas dialog script. So yeah, the original purpose was to program dialog sequences, and that's now in the naming. But a VDS script consists of several nodes, which in this case I'll list the nodes. So we have one node for the beginning of the program. We have a for. We have an if, a print, an else if, another print, an else, another print, an end if, a next, and finally the end. Kind of like that. So as these lines of code are read, each line of code is assigned a node. Now, if you're familiar with graphs, you have nodes and edges, and nodes are connected with edges. In this case, I use directed edges, and it's pretty straightforward, actually. Every node is connected to its subsequent node. Just like you're reading from top to bottom. So these are my directed edges. Now, in some cases, I might also have an additional edge that does something like this, but that's for a future update. So here's the initial state of the graph. So as I'm reading through these nodes, what I have to do is I essentially have to assign each one an indentation level. And what the indentation level will let me do is more or less specify how far each of these lines of code are indented. If you've programmed in Python before, it's kind of like the way Python uses indentation to define the scope of particular lines of code. In this case, however, me as the person that's writing the basic program, I do not have to do the indentation myself. So I showed you this here. I could just as easily have written this file so that all these lines are non-indented. The indentation is really for me. So, I can visually see what the structure of this program is. This is not how, the VDS script code is going to see this when it first loads this file. But, when I use the indentation level for, well, let's say this. Here we have, and maybe what I should do is I'll, in the margin, write a hypothetical program here. So let's say, let's let x equal 7. In fact, a command I use is set. So set x7, which by the way, I would like to include proper variable setting lines, terminology, whatever the right word is. In BASIC, I can write something like this. I can't do that now. I would like to be able to do that in the future. Shouldn't be too hard to add. In fact, I can furthermore add that, of those 1,800 lines of code, a good 900 of them, if not 1,000, are just for math. So, I can evaluate mathematical expressions using the correct order of operations, including functions. At least mathematical functions. So I haven't gotten to implementing proper functions in the programming sense, but I can use the mathematical ones like sine and cosine and log and whatever. But math is implemented correctly, so I can evaluate expressions with the order of operations, and that takes a good chunk of code there to implement what's called the shunting yard algorithm to do that. But anyway, hypothetically speaking, here's a program. So let's let x equal 7. Then I say if x is greater than 10, print cheese. And then if x is greater than 100, we'll print, I don't know, Swiss. It's getting close to dinner time, so I'm hungry. All right, and then I have to have endifs. So when this is running, since x is equal to 7, I need to know to skip all of this code. However, let's say x is 70. Well, then I need to know I only skip this line of code. So I use indentation levels to do that, and I think it's really pretty straightforward. The indentation level of this, first if statement's 1. And every block of code that's sandwiched between the if and the end if is then incremented. Now this print statement here with Swiss, since that is a member of the block for the if statement above it, that's actually indented to level 3. Like that. So if I know this condition is false, let me bring that back to 7 again. If that condition's false, then I know to skip every line of code with a higher level indentation. So when I had 70, this condition's true, so I move on to the next node, and I keep moving until I get to another condition, and as soon as that condition's false, I skip every line of code that's a higher level indentation. So again, if I were to change that 70 back to a 7, or 7.0, since this condition's now false, I skip every line of code or every node that has a higher level indent. So that indentation level is very useful. The only problem is, how do I get that in the first place? So let me clear the whole screen here, and I'll talk about how to do that. How do you compute the indentation level? Like, I'll give this a proper heading here. Computing the indentation level. This is such a crucial part of the loading process that I think it deserves its own little segment here. So the way this is done, well, first of all, I need to load the whole program. So I load all 11 lines of code, and I have all my nodes, but the indentation level of each node is not assigned. So as far as the way that the VDS script interpreter sees this, it does not see the indentation levels anymore. all 11 lines of code are the exact same indent. So what I need to do is I need to start iterating through all the lines of code and assigning each one an indentation level. And to do this, I need a stack. So the way the stack works is, maybe there's better terminology for this. If there is, to be honest, I don't know it. So I'm going to call them openers and closers. An opener is a line of code, like begin, for, if, that starts a block. And a closer is a line of code like end, next, when, endif, that closes a block of code. So when I encounter an opener, I need to do two things. I need to add the opener to the stack and then raise the indentation level by 1. And every time I run into a closer, I then check to make sure that closer matches the last opener, the top level opener in the stack. And if it does, I decrease the indentation level by 1. Now, this also gives me the opportunity to do some error checking, which I'll illustrate in a moment, but basically, if the closer does not match the opener, then I know I've done something wrong. And that's very important because, if I'm going to be writing hundreds of programs, I think it's, I'm human. So, it's inevitable. Eventually, I'm going to make a mistake with one of them. And I, want a chance to catch that. So, if I have some error checking functionality in the interpreter, then maybe I can, catch those problems and, basically terminate the program with an error message rather than having it run and then generating the wrong dialogue. So I want a picky interpreter because it forces me to write robust scripts. So let me walk through the process how this works. So the very first line of code here is begin, and begin is an opener. So I'm actually going to write the current indent level. And let me go ahead and write all lines of code too. So we have the begin statement, the for, the if, the first print, else if, the next print, else, the third print, and then finally the closers, endif, next, and end. And that should be, let me count. Yeah, it's 11 lines of code, so I didn't skip one. Okay, so we need to assign each one indentation level. And right now, the current indentation level is 0. So when we hit the begin node, begin is an opener. So I'm going to add that to the stack. Assign begin the current indentation level, but then because we added an opener to the stack, I'm going to increment the indentation level. Okay, now we move on to the next line. So the next line is for. Okay, well, let's assign its indent level. So that's a 1. But since for is an opener, I need to add that to the stack and then raise the indentation level again. So now it's 2. Moving forward, the next line of code is if. So we'll assign its indent level. And then since if is an opener, we need to add that to the stack and raise the indentation level again. So now we're at level 3. Okay, next line of code is the print. So we assign that a 3. Print is neither an opener nor a closer, so we can just move on. Now when we get to a closer, so else if is the first closer. In fact, else if is actually an interesting one because it's both a closer and an opener. In fact, I think it's the only line of code that satisfies, else. Both else and else if are the only lines of code that have both roles simultaneously. So when we hit that else if, I'm going to walk through this the exact same way the interpreter is programmed to do this. First thing it does is it says, hey, that's a closer. So let's check and make sure that this closer matches the last opener in the stack. And we see here we have a match. If is the appropriate closer that matches the else if. So since that checks out, there's no error reported. We're going to go ahead and eliminate if from the stack, drop the indentation level back to 2, and then tack on the new indent level. Okay, well now, else if is not only a closer, it's also an opener. So that is added back to the stack, and then you can raise that indentation level back again, and we'll move forward. Okay, print. So print is the next node. Our current indent level is 3. Nothing special about print beyond that, so we'll just move on. Else. All right, else is a closer and an opener. But since it's a closer, we'll check it with the stack. Else is an appropriate match to else if, so no errors reported. We'll go ahead and close. So take else if off the stack. Go ahead and drop the current indentation level, and then stamp that indentation level on the node. Furthermore, since else is also an opener, we put that on the stack, raise the indentation level again, so now we're back up to 3, and move forward. So next node is print. Stamp the indentation level. Nothing special about print beyond that, so we'll move forward. End if is a closer. Now it's only a closer, so end if does match with else, so that's an appropriate closer for the latest opener. So no errors reported. Strike that from the stack. Go ahead and drop the indentation level, and then stamp that indentation level. So if you haven't picked up on the pattern yet, basically it's a 3-phase process. Check for a closer, and if we do have a closer, drop the indentation level, stamp the indentation level, then check for openers. And so if we have an opener, we raise the indentation level. So it's always that pattern. Next is a closer. Next is an appropriate closer for the current top entry in the stack, so that'd be the 4. So since that matches, no errors reported. Drop the indentation level and stamp it. And then finally we get to end. End is an appropriate closer for begin, so that checks out. So strike that from the stack, drop the indentation level, and then stamp the indentation level. And if we get to the end of this and the indentation level is not back to 0, an error has to be reported. In fact, there's actually several opportunities here to catch mistakes, because not only does every closer have to match the top level opener in the stack, but also the indentation level can never go negative, and it has to end on 0. So at any point, if even those things go wrong, the line of code that's currently being parsed is reported. In some cases, it's more like there's an error around here, rather than this particular line of code. But that does give me some opportunities to catch errors, because like I said, I'm going to be writing dozens, if not hundreds, of these little basic programs, and inevitably, I'm going to make a mistake somewhere. So I want to know that. I think this also, I don't know how QBasic was programmed, but because obviously I don't have access to the source code for something like that. I made up everything I'm seeing here pretty much off the top of my head. I mean, using notions that I remember from QBasic and the like. So I guess it's not from scratch, but on the other hand, I don't have any hard reference materials either. I pretty much just had to figure this out on my own, how to do this. But I have to wonder if QBasic and the like, if they parse the program structure in a similar way, because one thing I noticed is every control structure has a unique matching ending control structure, such as or ending line, such as while and when. If you have a while loop, You say while, and then your condition, you have your lines of code, then you have wind, like that. So now I suppose wind is short for while end, but still, why not just do this? It makes me wonder if there's a reason why. Anyway, I think this would be a good stopping point for now, because I could go on for hours and hours about different aspects of how this works. And as I mentioned, this is still a work in progress. So I think for my next update, I'm going to talk about how execution works. And in particular, the part I'm working on sorting out right now is how function calls work. And more or less, I'm having to reprogram the entire execution aspect of the VDS script interpreter. So that's quite a bit of work ahead of me to do that. But I think it'll be worth it, because there are two things I need the interpreter to handle. It needs to handle function calls and using other basic programs as basically functions. Second, I need to be able to run multiple scripts simultaneously. So that'll be another challenge to get that to work. But that'll be update 2, how that works. Anyway, if you've stuck with me, so far, then thanks for watching, and have a good one, everyone.